Welcome back. In this video, we're going to talk about word stems and word stemming, as well as removing punctuation. These are going to be the next two steps in our pre-processing stage. Again, we'll work with an example sentence before applying all of this to our email dataset. I'm going to add a quick markdown cell here that reads word stems and stemming. Now, what do I mean when I say word stems and word stemming? You see, stemming is the process of reducing words to their base or their root form. The idea behind word stemming is to treat inflected or derived words in the same way. So for example, the words fishing, fished, fisher, and fishlike are all reduced by the stemmer to the word fish. Endings like ing in fishing or ed in fished are removed by the stemming software. Now, the thing to note about stemming is that the stemmer might not produce quote-unquote proper words. That is to say, you might not end up with a real word after removing the stem. So for example, the words argue, argued, argues, and arguing are all stemmed to the word argue. Now, this is not an error. The purpose of the stemming algorithm is to bring the variant forms of the word together and not to map a word to its paradigm form, if you will. The stemmer that I'd like to introduce to you is the de facto standard stemmer for the English language, the Porter stemmer. This algorithm was written by Martin Porter all the way back in the 1980s at the University of Cambridge. In a previous lesson, we've already imported the Porter stemmer functionality from NLTK at the top of our Jupyter notebook. Now it's time to put it to use. I'm going to copy this cell here, and then I'm going to paste it below my markup. What I can do now is simply save the Porter stemmer to a variable. So I'll just say stemmer equals Porter stemmer, parentheses. And then to use this stemmer, I'm going to go inside my for loop. Just before appending the words, I'll create another variable called stemmed_word, and this will be equal to the result of the stem method from the stemmer. So I'm going to use the stemmer, put a dot after it, call the stem method, and then here between the parentheses, I'm going to supply the word that our loop is looping over, stem the word, store it inside this variable here, and then instead of appending the original word, I will simply append the stemmed word. Now, looking at our example sentence here, the word makes is a clear candidate for stemming. Let me hit Shift-Enter and see what it will be stemmed to. Makes is stemmed to make. Now, it turns out this was only one word in our example sentence that was stemmed. Perhaps we should add another word that's a stemming candidate at the very end, just to try out how the stemmer works. I'm going to expand the example sentence with a few more words. So I'm going to wrap my line across 2 lines on Python so I don't have a very long sentence all in the same line. So I'm going to use that backslash, that escape character, which escapes me pressing enter on my keyboard. Now I'm going to add a few more words to my example sentence. Nobody expects the Spanish Inquisition. There we go. Let's see how our Porter stemmer handles this. So quite interesting. Nobody gets stemmed to nobody with an I. With expect, the stemmer drops the S. And with the word Inquisition, the stemmer drops the letters ION at the end. Now, one thing I'll say is that you're not actually limited to using the Porter stemmer from the NLTK toolbox. There's quite a few to choose from. There's almost like a menu. The reason you might want to use a different stemmer other than the Porter stemmer, for example, is if you're stemming a different language. Scrolling up to the top to our imports, a popular choice for other stemmers is the snowball stemmer. So NLTK .stem can also import the snowball stemmer. And the nice thing with the snowball stemmer is that if I come down here, copy this line, comment this out, paste it in, and substitute the snowball stemmer here, I can choose a language. For example, English, obviously. We can use the snowball stemmer with English. But if we go to the documentation here from NLTK, and we scroll down a bit to the snowball stemmer, then what you'll see is that there's other options too, right? There's Arabic, there's Finnish, there's French, there's German, there's Hungarian, Swedish, Norwegian, quite a few, Romanian, like the list goes on, right? Russian. So you can have a look. I'll put the link in the lesson resources. So yeah, if you ever want to stem words and use this tool on text that is not English, the snowball stemmer is your friend. Okay, so that pretty much covers stemming. The next thing that we'll do to clean up the email text and the words is to remove the punctuation. Our spam classifier is not going to be very interested in the punctuation for the sentences. We can see at the moment we still have these full stops in our output and a exclamation mark, and if we add question marks or anything else, it'll show up as well. To remove the punctuation, I'm going to copy the cell, paste it below, and then also just quickly add a markdown cell here to commemorate what we're doing. So I'll say removing punctuation, and then I'll delete a few of these comments here. Let's format this slightly differently. Maybe add the odd question mark here. Hit Shift Enter. And now we're ready to go. Removing punctuation is, well, I think there's like an easy way and there's a hard way. And I'll show you the easiest way you can do this. You see, Python strings have a fantastic method called isAlpha. So if you've got a string, say a single character, the letter P, and you put a dot after it, and then type isAlpha, just like so, then this will check if you've got a character or punctuation. In this case, the method returns true. But if we had, say, a question mark and wrote isAlpha, then this would return false. I'm going to move these cells up slightly. So we've got them up here. And I want to maybe pose a mini challenge to you. Can you modify our code in this cell so that all these special characters here, all these punctuation characters, full stops, question marks, exclamation marks, get excluded from the output? What would you change in our code here to accomplish this? I'll give you a few seconds to pause the video and then I'll show you the solution. Did you have a go? What I would do is to modify this condition here. Not only would I check if the word is part of the stop words, but I would also say that punctuation should not be included in our list. So we can take the word, put a dot after it, and say isAlpha, parentheses. This bit of code will only return true if it hits an actual word, like boy or dull. It will not return true for the full stops or the question marks. Let's check it out if it works. Surprise, surprise, I've planned out this tutorial and it does work. So there you go. This is how you can use a built-in method from the Python strings to check for punctuation and exclude it if necessary. In the next lesson, I'm going to show you how to tackle the HTML tags in the emails. I'll see you there. Stay tuned.